Hello, I would like to welcome you to this session on effective tools for design analysis and multi-objective optimization using the SDI Tools software. The SDI Tools software has been developed to support systems engineering, design for Six Sigma, and product development activities. The tool set includes the Triptych tool and the Apogee tool as the two primary tools within this suite. Additional tools that are available include the Reliability Test Design tool, Distribution Explorer, and the PNC Test Effectiveness Calculator. In the Apogee tool, which is used primarily for analysis and optimization activities, it includes a sensitivity analysis tool, a sensitivity statistical allocation tool, Monte Carlo, and multi-objective optimization tools. So let's talk about what we're really trying to satisfy, what we're trying to achieve when we pursue analysis of a problem using the Apogee tool set. Well, we have various requirements that have been flowed down. We have various capabilities that may be available in terms of achieving certain characteristics of certain parts or parameters. And let's say that we've developed a model that describes the relationship between the various parameters and the particular response that we're analyzing. What we want to understand is what is the quality of the end result that we will obtain. So we're starting our quality analysis initially during the design phase and not only in the manufacturing and verification phases. So here we've represented with this requirements hierarchy shown on this chart that we have a particular Y response that's a function of 5 variables, A, B, C, D, and E. Each one of these parameters or variables A, B, C, and D have a particular nominal value that may be assigned to each one, and there may be a specification that's also assigned to that parameter, and there may be some sources of uncertainty that we can attribute to that individual parameter also. The sources of uncertainty could be manufacturing tolerances. They could be variations due to environmental conditions, usage, wear characteristics, user environments, whatever the case may be. But each parameter is very likely to have some type of variation that may be normally distributed or may not be normally distributed. So here we have each of our parameters defined with some characteristics related to the nominal values and the uncertainty characteristics that may be experienced for that particular parameter. Now, to analyze our response, Y, for this result that we're looking at, we need a model. The model can be an equation, it can be a simulation, it can be an Excel workbook, hardware, whatever it may be, but is it something that will allow us to manipulate the parameters, in this case A, B, C, D, and E, in order to predict what the Y response will be. And we'll assess our design using these models. Now, what we can achieve with the Apogee tool set is that we can take a problem as described here in this diagram, define our X's, A, B, C, D, and E in this case, as parameters with sources of variation. The equation in the worksheet describes how those X's will achieve the Y response. And then performing the analyses we just discussed, we can predict the uncertainty of the Y response. Now, the value that this will provide to your analysis type activities is that not only are we interested in predicting the nominal or maybe the target response due to the nominal values of each one of our X parameters, but we're also interested in understanding what is the variation of the response, which is going to be due to the translation of these X's by the model or the equations as influenced by the variation of each one of these X parameters. So if we can predict the variation of this Y response and we compare that to our lower spec limits and our upper spec limits, now we can get an assessment or a prediction of what is the probability that we will be non-compliant with a particular specification that exists for this particular condition in our design. So basically, through the probability of non-compliance metric, we are predicting quality, and we're understanding at the very beginning, do we have a design that will satisfy our specifications with a defect rate of possibly 1 out of 1,000,000, or do we have a defect rate that could be 1 out of 10, or anything else that may be from 0 to a total 100% non-compliance. So this assessment is performed early and allows us to evaluate the effects of variation of parameters on the variation of response and the potential consequences. So let's go through step by step what you might incur during a design and analysis activity for a particular design. The first thing we need to do is identify what are the critical requirements that we're trying to satisfy. Now, these requirements were determined as a result of your analyzing your stakeholder information and determining the requirements and specifications for the key characteristics of your design. The next step will be is to determine, well, how are we going to achieve these requirements? Well, if you had attended the session on the triptych tool set, you know that one of the things we focused on is determining requirements and then determine the alternative or the solution that would allow us to achieve that particular requirement. So basically, once you have a solution, it is the translation of these X parameters to achieve a Y response. Well, can we go develop an analytical model or simulation that describes that particular requirement Y as a function of some X's that are combined based on the option or the alternative that you identified for this particular solution? Then, from your models, we can go examine each one of our X's and let's determine what is the variability that could potentially be allocated to each one of these X parameters. So in other words, variation is basically the same thing as assigning tolerances to individual parameters. Let's think about what tolerances might be assigned to the individual X's in this particular design. The next step would be to go identify then, in terms of variation, any known sources of uncertainty or capabilities that may exist in terms of the variation with respect to producing a part, purchasing a part, acquiring a part, whatever it may be. Once we had the model in place and the sources of uncertainty identified, then we can go analyze the response Y due to these uncertainties and determine what the response uncertainty will be due to the uncertainty of the X's themselves. Then, given that you have multiple design requirements that you have to satisfy, then we can pursue an optimization type problem where we optimize the design for multiple responses against particular constraints and goals that we may have assigned. So how would we perform this analysis and optimization using the Apogee tool set? Well, first off, let's go identify what our key requirements are. They could be basically anything. Cost, power, time to some event, volumes, weight, frequency, yield, whatever it may be, anything that's a product or process result that we need to achieve. Then for that particular result, think about how that result will be obtained and can we express it mathematically. So it may be that you can go develop equations from first principles, from physics. It may be that in order to get to the equation, you need to go perform a design of experiments and come up with a regression type equation that you could use to predict the response due to certain input conditions. If you have historical data, then you can go use regression analysis to also develop an equation. So basically, let's go find out what the basic relationship is, a mathematical relationship that will describe a Y response as a function of the X's, and possibly implement that in an Excel worksheet. Now then, if we have no idea what the variation, allowable variation, could be for these individual parameters, whether they're diameters or material densities or resistances or capacitance or whatever it may be, well, we can start with the statistical allocation tool and say, okay, what response characteristics are we trying to achieve? What tolerances do we need to maintain on that response? And what is the desired probability of noncompliance that I would like to achieve? Well, with the statistical analysis tool, we'll have defined the model using our Excel spreadsheet. We will identify the variation that's allowed on the response, and then we can go in and use the tool to allocate standard deviations or identified tolerances to each one of the parameters in order to meet a particular probability of noncompliance on the response and satisfy a particular variation or standard deviation on that response. So the screenshot that we're looking here for the statistical allocation is actually a result that's produced by choosing to do an allocation on your defined spreadsheet model that we set up in Apogee. And then we can use this allocation worksheet to go in and exercise different tolerancing conditions in order to achieve the desired response results that need to be satisfied. So this would be one capability and one function you could perform using the Apogee toolset. Now let's say that either through statistical allocation or through a past experience or known information that we already know what the variations are that will be assigned to each one of our parameters. Well, if that's the case, then we can go in and define a particular distribution or probability density function that we will assign to the diameters, to thicknesses, to densities, to resistors, capacitor values, whatever your particular parameters may be. We can associate certain statistical properties with each one of these as part of the definition of your X parameters. So in Excel, we've gone from defining each parameter as a nominal or a single value to now being a statistical quantity, where we can now use this analysis or this variation as part of our analysis approach. The next step will be to analyze the response Y uncertainty that is due to the uncertainty in the X's that we've just defined. So this can be performed using sensitivity analysis or using Monte Carlo analysis. Sensitivity analysis is kind of an empirical approach that is based on using the defined mean and standard deviation of each one of your parameters to predict what the mean and standard deviation would be for the desired response. Once this response variation is identified and predicted, we can now compare this variation with our specification limits and predict the probability of noncompliance with respect to this distribution and your specification limits. So we can identify very easily, or do we have a design that will be very satisfactory or marginally satisfactory or even unacceptable, and then we can identify what needs to be done in terms of addressing variations to improve this overall end result or this performance. If you have distributions that are non-normal, then you can also make use of the Monte Carlo analysis technique that's built into the Apogee toolset. And in this case, we will actually do random sampling from each one of the defined distributions, run through a series of trials that will be user-defined, and determine then what is the response variation that we would expect to achieve as a result of a number of trials of selecting X's in a random fashion from these distributions and using that information with our response models. So in this case, we can now look at the performance results for and see what not only the nominal characteristics are, but what the uncertainty characteristics are, along with the contribution of each one of these parameters to this overall variance. So using sensitivity analysis, Monte Carlo, and statistical allocation, we can do analyses on individual responses from our design. But the next question may be is, can I achieve all of these response results simultaneously in the final design? How do I select my tolerances and my X values to get to a combined set of characteristics that will be necessary to satisfy your stakeholders? Well, this is where we need to optimize the design for multiple responses, constraints, and goals. And in the Apogee toolset, once you've defined your constraints and goals and the various responses you're analyzing, then we can go perform a multi-objective optimization. You can have a variety of constraints that you may have defined for a particular design. You may have a set of goals that you've identified that you would like to achieve. And the optimization tool will then go through and find what is the preferred value for each of your X parameters. It could be nominals or uncertainties that would be needed to satisfy certain attributes or aspects of your response conditions that go against your specifications. So these responses that you analyze, you could be analyzing the mean response, you could be analyzing the standard deviation of the response, or the probability of noncompliance response as part of your optimization problem that you're pursuing. So in summary, Apogee provides methods for analyzing performance and quality very early in your development process. We can start understanding the impact that parameter uncertainty will have on specification compliance for individual responses. Using these techniques, you can simulate a design, you could simulate a manufacturing process, you could simulate operating conditions within your design, and then you can assess that design against conflicting requirements in order to identify potential solutions that could optimize and overcome the conflicting requirements that you may be dealing with. Using the optimization approach, you're performing a trade study. We talked about looking at various design alternatives when we discussed the triptych tool. And actually, when you run an optimization, you are evaluating thousands of design alternatives in a matter of seconds or minutes, and then using the optimization tool to help you identify what the preferred solution may be and give you a rank order of candidate solutions against a particular model that you've identified. In addition to just helping you define the design and understand the goodness of the results, you're actually performing risk assessment and risk management and starting this very early in your development process. So we found that the Apogee tools really do support a variety of product development tasks, systems engineering, and design for Six Sigma activities. It allows you to analyze all of this information in simple spreadsheets, and then you can share the spreadsheets with others also. So they're just standard Excel worksheets and workbooks once you've completed the analysis using the SDI tools. We found that these techniques really do enhance the productivity for engineers to use established and proven methods as part of their development process. And you can use these techniques to analyze the top-level system response, a characteristic in assembly, a condition over a component, analyze a process, whatever it may be, is the Apogee tools will support these type of activities. So I want to thank you for your attention in this tutorial. If you have any questions, feel free to email me or call me, and I'll address those for you. If you want to give the Apogee tool a try, it's also within the SDI Tools version 3 software, which you can download at stat-design.com. Your initial installation will come with a free 7-day trial for the complete tool set, and then if you're interested, then we can talk to you about extending your trial version or to setting you up with a license, either a limited term license or with a perpetual license. So I hope that you found this information useful. I hope that you're thinking about ways that you could apply these concepts in your design activities, whether it's for parts or processes or systems or whatever. And we look forward to working with you in the future. Thank you very much.